In this problem, we're going to solve the equation negative 2 times the quantity x plus 3 equal to 4x minus 6 times the quantity x plus 1. Recall that when we're solving a linear equation, it's possible that we end up with our solution being one real number. It's also possible that we get no solution if we find that the resultant equation is an inconsistent equation, or it's possible that we end up that it ends up that all real numbers are a solution. And in that case, we'd be looking for the resultant equation to be an identity. So to start, let's write this equation. So we have negative 2 times the quantity x plus 3 equal to 4x minus 6 times the quantity x plus 1. So to solve this equation, the first thing we need to do is simplify each side. On the left, we're going to use distribution, and on the right, we'll use distribution and then we'll combine like terms. So we'll use the commutative, associative, and distributive properties as needed. After that, we'll use the addition property of equality and the multiplication property of equality to isolate the variable and then eliminate any possible coefficient. So on that left, let's distribute that negative 2 across x plus 3. And so we'll have negative 2x minus 6 equal to, and on this right side we have 4x, and we're going to distribute the 6 across x plus 1. Again, we're doing that distribution first because multiplication precedes subtraction. So minus 6x minus 6. Okay, so now we're done distributing. We want to combine like terms and continue simplifying each side. The left side will just stay negative 2x minus 6, and on the right side we can simplify 4x minus 6x into negative 2x. So we have negative 2x minus 6 on the right side as well. At this point, we can see that this equation is an identity. The left side and the right side are identical. If we want, we can continue. And our next logical step would be to add 2x to each side. So the reason I'm continuing is that it's sometimes helpful to continue solving until we get either a single value for x or we get one number equal to another number. So to continue solving, I'm going to add 2x to each side, and so I've done that to the left side, giving me negative 2x minus 6 plus 2x, and on the right side I have negative 2x minus 6 plus 2x. So that's going to leave me with negative 6 equal to negative 6. And at this point, these are all identities. So this next one was an identity, and then this last one is also an identity. So once I reach an identity, any property of addition property of equality or multiplication property of equality will result in another identity. I've broken it down to negative 6 equal to negative 6 because without having x equal to a single number or having x on each side, I know for absolute certainty that this resultant equation is an identity and that every value of x will make this true. So I'm looking at this equation and seeing negative 6 equals negative 6, and I ask myself, for what values of x is that true? And the answer is for all values of x. So all real numbers are solutions. So I'll write that down. All real numbers are solutions. And so my solution set is the set of real numbers. So if I want to write the solution set, I'll say then that the solution set is the set of all real numbers. And when I use set builder notation to write the set of all real numbers, I write a curly bracket x such that, then after that I write x is a real number. And then I end that with a curly bracket. And so that's saying the solution set is the set of all real numbers.